Welcome to RiverRoot, where we bridge the gap between technology and nature. In a world struggling with water pollution, the most advanced solution might not be a machine, but a plant. Today, we're unveiling the living filter blueprint featuring a true ecological powerhouse, water celery. Water celery, or Enanth javanica, is more than just a nutritious vegetable. This perennial aquatic plant is characterized by its exceptionally developed white fibrous root system. It is these roots that allow it to occupy a unique niche in water purification, acting as a structural anchor for life. Our waterways are under threat from eutrophication, an excess of nitrogen and phosphorus from industrial and agricultural runoff. This leads to devastating algal blooms that deplete oxygen and destroy aquatic ecosystems. Traditional mechanical cleaning is expensive. Water celery offers a low-cost biological alternative. Most purification plants go dormant in winter, but not water celery. It is incredibly cold-resistant, surviving temperatures as low as -10 degrees Celsius. In regions like Wuhan, it maintains a natural overwintering survival rate of about 76%, ensuring that water purification continues even during the coldest months. How does it work? First, through direct absorption. As water celery grows, it consumes inorganic nitrogen and phosphorus to build plant proteins. Data shows that between January and April, a single square meter of water celery can remove 52.23 grams of nitrogen and 11.51 grams of phosphorus directly from the water. Beyond absorption, we have the root zone theory. Water celery transports oxygen from the air down to its roots, releasing it into the surrounding water. This creates an aerobic microenvironment around the root hairs, which drastically accelerates the degradation of organic pollutants. The roots also act as a biological city. The dense root network provides a massive surface area for beneficial bacteria, like nitrifying bacteria, to attach and grow. Research shows these floating beds can increase the number of nitrogen-cycling bacteria by 1 to 4 orders of magnitude compared to open water. Let's look at the numbers. To move water from Class V, polluted, to Class 3, clean, you need to remove specific amounts of N and P for every square meter of water celery floating bed. You can purify approximately 52 cubic meters of water based on total nitrogen removal. At RiverRoot, we studied different planting methods. While floating beds maximize biomass and are great for deep water, sand-based planting in shallow areas helps roots maintain higher activity and oxygen secretion during the peak of winter. This plant is tough enough for industrial applications. It can treat pig farming biogas slurry with removal rates for nitrogen, phosphorus, and chad often exceeding 93%. In urban black odor rivers, specific stubble heights, like 19 centimeters, have been shown to optimize these cleaning effects. For hobbyists, water celery is a game changer. In a 300L tank with 500 white cloud mountain minnows, its roots provide a natural nursery and sanctuary. In turtle tanks, it acts as a high-intensity nitrate sponge while occasionally serving as a healthy snack for your pets. The key to a living filter is balance. You must prune the plant before old leaves decay, as rotting tissue can release nutrients back into the water. By harvesting overgrown celery, you are physically removing solidified nitrogen and phosphorus from your system. This is the most effective form of a water change. Sustainability must be practical. Water celery doesn't just clean. It produces a harvestable crop that is a valuable winter vegetable. This pig biogas vegetable model creates an economic benefit while restoring the environment. True win-win for farmers and the planet. To make your living filter thrive, remember 2 things: light and air. Water celery needs sufficient light. Ideally, 600OK 650OK to maintain its metabolism. Also, in dense indoor setups, ensure 24-hour aeration to prevent oxygen depletion at night when plants aren't photosynthesizing. Harnessing the power of plants like water celery is how we build a cleaner future. If you found this deep dive valuable, please show your support. Like this video, subscribe to RiverRoot, and hit that notification bell. Your support helps us continue exploring the science of nature. Let's grow a cleaner world together. See you in the next one.